Hi. So today we're going to start talking about oblique triangles, which is pretty simple. It's just any triangle without a 90-degree angle. So any triangle that's not a right triangle is an oblique triangle. So all of our tools that we've had so far, like SOHCAHTOA and the Pythagorean theorem, don't work anymore. So first, let's generally talk about how we label these things. What the convention we follow when we label an oblique triangle is we use capital ABC for the angles. So I'm going to put angle A here, angle B here, and angle C here. Now, is there a reason I labeled it ABC and not ABC or ABC or some other way? Absolutely not. It doesn't matter. The important thing is that we have to label the corresponding side or the opposite side with the same letter. So the side opposite angle A is side A. The side opposite angle B is side B. The side opposite angle C is side C. So lowercase letters for the sides, uppercase letters for the angles. However you label it, if this were angle A, this would be side A. That's the only important thing, is that they all match up. Otherwise, the formula I'm about to show you doesn't mean anything and it doesn't work. Okay, so the first tool in our toolkit for solving oblique triangles is called the law of sines. I'm not going to derive this formula or prove it for the purposes of this video. It's pretty easy to do. It comes right out of like SOHCAHTOA and some stuff about the area of a triangle. So it's not hard to wrap your head around why this works, but here's what it is. So it just says that the sine of angle A over A has to equal the sine of angle B over B, which has to equal the sine of angle C over C. And that's it. That's the law of sines. If you had to say this just in layman's terms, you would say the ratio of the sine of any angle in any triangle, no matter what, the ratio of the sine of the angle to its corresponding side is exactly equal for all three angles, right? So this over this equals this over this equals this over this. Now, you can use this on a right triangle, and I can't stop you from using it, and I'm just always going to caution that we always want to use what's easiest. So if I give you a right triangle and tell you to solve it, there's really no reason to use this. You can just use SOHCAHTOA and the Pythagorean theorem and right triangle stuff. In fact, what you'll find is you're kind of just reinventing the wheel, because if you try to do this on a right triangle, the sine of a 90-degree angle is 1. So this just becomes like 1 over A, and it basically just simplifies to, you basically are just using SOHCAHTOA. So again, I can't stop you from using this on a right triangle. It doesn't work, but you don't need it. Okay, so what do we need it for? Let's set up an example. And I'll give you a triangle to solve. All right, let's say we have a triangle like this. This is a 100-degree angle. This is, say, a 30-degree angle. And the length of this side is 2. Okay, so that's an oblique triangle. It's not good. It does not have a 90-degree angle. Hopefully, you know, if you just charge ahead and tried to use something like the Pythagorean theorem on this, you would realize there's no hypotenuse, so it doesn't apply. Let's label things. Let's follow the convention I use. I just kind of start at the bottom right corner and go counterclockwise. Is there any particular reason I do it that way? Absolutely not. I just do. So just when you have to set up a triangle yourself, just be consistent. So in other words, if that's angle A, that's side A. And if that's angle B, side B is known, that's 2. And this is angle C, this is side C. Unfortunately, capital C and lowercase c look exactly the same. Okay, so in order to use this bad boy, you have to have one of these things. In other words, you have to have angle A and side A, or angle B and side B, or angle C and side C. We actually don't have that yet. Right, we don't have that right now. We have two angles in one side, but we don't have the angle that corresponds with this side, and we don't have the sides that correspond with these angles. But in any triangle, no matter what, the sum of the degrees of all three angles has to add up to 180. So that kind of comes to our rescue. Anytime we're given two angles in any triangle, oblique or right or whatever, we get the third one essentially for free. I mean, you can almost do it in your head. If these add up to 180, then this third angle has to be 50. So go with what's easiest off the bat. Get angle B. Angle B is 180 minus 100 minus 30, which is 50 degrees. So since we are solving the triangle, every time we make a little bit of progress, we want to kind of put a box on our answer. Or we can go back and label it on the triangle itself, but let's keep it neat. So you get the first piece of information very easily. And now we have what we need. We have angle B, and we were given side B. So now we have one of these things, so we can use the law of sines. So we need side A and we need side C. There's no reason to do one of them first, so we'll just start with, I don't know, let's start with side A, the little one. So the law of sines gives us that sine of 50 degrees over 2 equals sine of 30 degrees over A. And now we have to do whatever algebra it takes to solve this little equation for A. So there's a lot of ways to do what I'm about to do. For most of you, the simplest way to look at actually using the law of sines will be just cross multiply. Since you always have a fraction equals a fraction, you don't want to deal with those fractions. You got to get A out of a denominator in this case. So algebraically, the quickest way to get out of here might be by cross multiplication. If you're comfortable using your calculator, you can essentially do this without really showing any work. But as I will say not to do is don't punch sine of 50 over 2 into your calculator right now and then round it. If you do that, in the next step, you'll be using a rounded figure, and then you'll round your solution, and then it'll be wrong. And if you were then to use your side A for that one to go ahead and get side side C in the last step, then that would be wrong. So do any algebra you have to do and just do it on your calculator at the very end. We'll talk about, if you're brave, how to do it faster. Yeah, so by cross multiplying, okay, this times this, A times sine of 50 degrees equals 2 times sine of 30 degrees. And then since we need A, just divide both sides by sine of 50 degrees. So A equals 2 times sine of 30 degrees over sine of 50 degrees. That's the exact answer. That's the thing that we want to now punch into our calculators and round. So let's do that, and then I'll just kind of walk you through maybe a couple of other ways to do it. You can make use of your calculator a little bit more. So at this point, I think you know how to crunch stuff into a calculator. You get A is about 1.31. And then circle that, because that's a part of our solution. Anytime you're doing any kind of geometry problem, really, you want to make sure that your answer visually makes sense. If I tell you that this side is 50 and you come back at me, that this side is 2 and you come back at me with this side is 50, well, that doesn't look right. It should be tiny, right? It should be very small. So 1.31 seems about right. Okay, so just to kind of walk through another way to do this, if you come back here, remember those little triangle diagrams we were talking about last week? Just forget that this is a fraction for a second, and just consider that, okay, if this is sine of 30 over A, then that means A has to be sine of 30 over all this. So if you're bold, you can jump right to, okay, A is sine of 30, and this is going to be a compound fraction, over sine of 50 over 2. And now there's a couple ways you can think about this. You can think about that as, okay, if dividing by a fraction is the same thing as multiplying by the reciprocal, so I can think about this as sine of 30 times 2 over sine of 50, which, would you look at that? That's exactly what we have here. Or your calculator actually can do a compound fraction like this. I don't have a way right now of holding the calculator up to the screen and having you see it. But if you go to alpha F1, this is the top left button on your calculator. It's the same as the y equals button. It'll pop up with a little submenu, and you can choose this n over d, which just gives you a fraction, and you can literally type this into your calculator. You can just literally type a compound fraction in and punch it in, and you'll get the same figure. So, like I said, if you're brave enough, you can do that right from here. You can say, okay, a has to be sine of 30 over this whole thing, and then punch that all into your calculator. Now, if you had to show more work than that, maybe like on a math test, you might want to kind of bother explaining what you did, or just write down this step, and then your math teacher would know, hey, they just punched this into a calculator, and they got the right answer, so we're good. Okay, so I'm never going to tell you you have to do it one way or the other. There's a lot of different ways to get the algebra correct from here. Okay, so the nice thing about this is we're just going to use this same number, again, sine of 50 over 2, to get side C. And you're going to see the algebra is literally exactly the same. We're just going to end up doing the same thing twice. So to get side C, we're just going to come back to sine of 50 over 2 equals sine of angle C is 100 degrees over C. This is exactly the same math as this. The only thing that's different is this number, 100 degrees. So however you did this, it's going to shake out the exact same way. If you cross multiplied, you're going to end up with something that looks like this, only this is going to say 100 instead of 30. If you did it the kind of quick way, this is going to be 100 degrees instead of 30. So literally, you could just go back and you could go to like the last thing on your calculator where it like copies the last thing you did and just replace 30 with 100 and hit enter and you're done. Or you can do the algebra over again. Choice is yours. So, however you do it, I mean, I already walked you through this example, so it's going to be the same. What you get when you do that is that C is about 2.57. And we're done, right? We were given 2 angles and one side. We got the third angle easily because we always can, and then we use the law of sines to get the other 2 sides. So what you'll see if you look in your book and stuff is that they break up oblique triangles into a number of different cases. The case we just did is called the angle side angle. Or for short, ASA. I don't like to get too bogged down in thinking, okay, is this ASA? Is it angle side? Is it side side side? What I want to do is just develop a general strategy for solving oblique triangles, because we do have something else called the law of cosines. That's my next video. But so here's just my general word of advice. Anytime you have an angle and its corresponding sides, you can and probably should use the law of sines because it's pretty easy to use. If you have 2 angles and one side, you can get the third angle basically for free, and then you're back to what I just said. Then we had the angle and the corresponding side. We just had to do a little bit of stuff to get it. If you have all 3 sides, this is useless because you don't have any angles. And then there's another case where you have 2 sides and they're included angle. There's no easy way to get the third side in an oblique triangle. And if you only have 1 angle, you can't get the other 2, so this is also useless. So just remember that. Just for the test or whatever, just remember that. Anytime the setup gives you an angle and its corresponding side, or you can easily get an angle and its corresponding side, you can do the entire rest of the problem just using the law of sines. You might have to do it twice, but as we saw, it's pretty much the same thing. So if you're comfortable with this first step, you're going to be comfortable with this second step. And like I said, in those couple of cases where you're not given that, we need the next thing, which is called the law of cosines, which I will talk to you about very soon. Thank you.